First example for topic 3 is going to be looking at making use of the derivative of cosine, sine and tangents, but also making use of our chain, product and quotient rules that we've looked at in the first two topics. Our first example of y equals 3 cosine of 2x is going to make use of the chain rule. Because we have cosine of a function, we need to make sure that we derive the cosine and then multiply that by the derivative of the function. So our result of 3, derivative of cosine is minus sine. The 2x function remains, and we multiply that by the derivative of 2x, which is 2. If we were to simplify that, dy and dx, we get negative 6 lots of sine 2x. So in its simplest form, the 3 and the negative 2 have multiplied, sine 2x remains. For the second example, in part B, we're making use of the product rule. 25e to the 2x is our u term multiplied by sine of x. So you may choose to come over here and list those items out. So u equals 25e to the 2x. U dashed, bringing the exponent's derivative of 2 to the front gives us 50 e to the power of 2x. V is going to equal the sine of x and then the derivative of v dashed, will equal cosine of x. So now that we have those four things listed, we can come back to our derivative function. Using u dashed v plus uv dashed, we end up with our 50e to the 2x multiplied by the second term, so sine of x, plus the first times by the derivative of the second, cosine x. So leaving it in that form for chapter 2, when we do get to chapter 3 and apply the applications, we may take out the common factor of 25e to the 2x, but as I said, for chapter 2 that's how we would leave this one. For example C, we've got the derivative of a tan function, so in the notes there was two alternatives there. We could leave it as 1 over cosine squared, or I find simplifying as just sec squared is a little bit easier. Because we've got a function, tangent of a function, we must make use of the chain rule. So we keep the sec squared of that function, and the chain rule then makes use of the derivative of the function in the brackets, which derivative of 2 take x is just negative 1. If we're to simplify that, it is just going to become negative sec. Of the function 2 take x. Last example we're going to look at again makes use of the product rule. We have cosine of 3x squared as our u term. Derivative of that equaling, again making use of a similar rule to what we did in A, having to find the derivative of cosine, which is negative sine, keeping the 3x squared as the function, but then multiplying that by the derivative of the function, which would be 6x. The second term of v would equal sine of 2x, and then the derivative of that, v dashed, is going to be derivative of sine is cosine of the function 2x, and we're going to multiply that by the 2. So 4 things listed out, we can then go ahead and substitute that into the derivative formula, and we get negative 6x sine x times by the second of sine x sine 2x plus the first times by the derivative of the second, which is 2 cosine 2x. Give that a bit of room, move these over. So for example 3.1, we've got our 4 solutions there. Both B and D could be simplified slightly, but for chapter 2 that's how we'll leave it.